When we're doing conversion factors, the first thing that you need to understand is when you see a table like this, that it's set up in terms of your base unit. So these powers of 10 are in relationship to the base unit. For example, if you're looking at kilometers and your prefix is kilo or K, that's going to look like this in your problems. 1 kilometer is equal to 10 to the third meters. So that means 1 kilometer equals 1,000 meters. If you're looking at milli, which is 10 to the negative 3, that's 1 divided by 1,000, 1,000ths of a meter, or 0.001 meter. So these powers are in relationship to your base. Now when you set up your conversion factor, you have to use two quantities that are equal to each other. When you're going, in this example problem, express 5.712 grams in milligrams. So you're going from grams to milligrams. You've got to set up a relationship that is equal. 1 gram equals 1,000 milligrams. You can put it as a ratio either way. These all say the same thing. You just need to use the ratio that cancels the units that you want to cancel, which means that you're putting your unknown on the top. So 5.712 grams this is understood to be over 1. You're going to use the one that cancels grams, so milligrams is our unknown, it goes on the top. 1,000 milligrams per gram. Now grams cancel, leaving our units in milligrams when we multiply. When you go across the top, you're multiplying and dividing by the bottom. So 5.712 times 1,000 is 5,712 milligrams per gram, or in 5.712 grams. This is the same thing we did using this chart. And you can do it moving decimals this way, but say I have to convert between kilometers and millimeters. That's going to be a little bit more difficult to do using conversion factors because we don't have a relationship between kilometers and millimeters. In that case, you would go from kilometers to meters and then from meters to millimeters. So those would be like two-step problems. Even if you can do it using this chart, I need you to learn how to do it using what's called dimensional analysis. If I tell you to use dimensional analysis to solve a problem, it should look like this, where I can see that you're canceling units. The reason why is because later in the class we'll be using dimensional analysis to change units, and it's better to learn the process with easier units.